All right, guys, let's do this. Let's start. Let's go through, yeah, let's go through these different shapes. I tried to check in with everyone, but I don't think I got to everybody's answers. I saw you at least once, but I didn't get to check everyone. So here's what we got to do. We got to make sure that everything that we have filled in here is accurate, because if it's not accurate, then you might be studying the wrong material, okay? I think a lot of us learned about these a little bit more than maybe we initially knew, and we learned some words that maybe we haven't heard in a while. I know one word in particular that we all kind of struggled with at first, okay? Yeah. So let's go through these. Prisms. If I checked with you and verified that what you had was correct, then tell me about a prism. Prisms have two something bases that are congruent what? Lana. They have two parallel bases, correct? They are congruent what, Lana? Polygons. That was the word that some of us got stuck on. Polygons. Polygons would just be a closed figure that's made up of line segments. A circle is not considered a polygon, right? It's not made up of line segments, all right? Now, every face of a prism that's not a base is called a lateral face. So the lateral faces of any prism, like for instance, if I grab this hexagonal prism here, every other face is a what on a prism? Lauren? Thank you. That is a rectangle. And it doesn't matter the prism. We have a triangular prism floating around. Same thing. I could get a square prism that's going around as well. I don't have it, but I could get like an octagonal prism that have octagons. It doesn't matter. Every single one of them, all the lateral faces have to be rectangles. So we name these. You heard some odd names in there. They're named how? Riley? Yeah, whatever the base is on a prism, that's how we name it, guys. And the base does not have to be the bottom, just to clear up that misconception. Like if I take a hexagonal prism like this, it's not, the base isn't the side that it's resting on necessarily. It could be, but it's always the non-rectangular face, if there is one. Now, if you have a rectangular prism, then every face is a rectangle, okay? So obviously it's a rectangular prism, but go by that right there. All right, so the three shapes. What's shape number one? Raise your hand and tell me. Cameron. That's a triangular prism, yes. Okay, shape two. Got Weston? Yeah, we just go square prism. That one we don't have to make any harder than it needs to be. What about C? Marco? Yeah, that's one of those hexagonal prisms, or hexagonal, however you want to say it. All right, moving down. So we had two different types of pyramids floating around for you guys to analyze. Either one, can I borrow this from Maddie? Either one had the same characteristics. Pyramids have exactly, now the groups I stopped and talked to about this, probably should have clarified that I wanted the word one here, probably to assist you a little bit. But it has one what? Riley. It has one base. Yes. Hold on a second. So it has one base. Pyramids only have one base. The shape of the base must be what? Lane. Well, it could be, but it doesn't have to be. Like this is a square pyramid here. So what would we? Polygon. Yep. You could have a pyramid that has a base that's a hexagon, or a pentagon or an octagon or something like that. It's possible. It's not common, but it is possible. All right, the lateral faces. So every other face on a pyramid has to be what? Maddie? Well, it is slanted, but what shape are we talking about? Has to be a triangle, right? If it's not a triangle, then you don't have a pyramid. All right. Same thing as prisms. Pyramids are named by their bases. So whatever the base is, that's how we would name it. So the one on the left here, we would call that a rectangular pyramid. And the one on the right, even though it's not really labeled, I think we could probably call that a square pyramid. It just, if nothing else, just to make it different. Probably should have labeled that a little better. Okay. All right, then we moved on to cylinders. Who has the cylinder? Got a cylinder there? Thank you. I'll take that too. So with a cylinder, there are not any other names for a cylinder besides cylinder, okay? You could have a tall one, a short one, a wide one, a thin one, but it's not like you have different types of cylinders, because every cylinder has two bases that are parallel, congruent. What? Well, it has to be. All right, if they're not circles, if they don't have circular bases, then you don't have a cylinder. But the lateral area, now I probably gave you a little too much with this diagram here, but the lateral area of every cylinder, and this is going to be important when we start talking about surface area, is what, Marco? Yeah, if you unraveled a cylinder, you're going to get a rectangular region in the middle there. Just like if you took a piece of paper and rolled it up to make a cylinder, the piece of paper is a rectangle, but it would serve as the lateral area when everything's put together. All right, now we had cones, last shape we talked about. Cones have one what and one what? Cameron? One base, one vertex. And I'm actually going to clarify with the base has to be a what? Lana? You got, yeah, so let's say one circular base. And one vertex. Because if I had a cone and all of a sudden its base went from a cylinder, or I'm sorry, a circle to a polygon of some sort, then it turns into a what? Think about a cone. If it went from a circle to a triangle, let's say, or a rectangle, right? It would be a pyramid now. And the other way it works the same. With a pyramid, if I change that base into a circle, then it has to become a cone. All right, last one here for this page. Polyhedrons is a word that I'm sure you guys use all the time. All the time. So we're very well versed in the word polyhedron. I'm going to skip the first part because I'm going to try to lead you into answering this question. But of the solids listed in this section, only the prisms and pyramids are polyhedrons. Okay, so I've got a prism, I've got a pyramid. Now the definition, it says a polyhedron is a solid with a what for each face. Now think about what prisms and pyramids have. Got both here. Versus like a cylinder or a cone. Like think of characteristics. What is the defining characteristic between these shapes? Polyhedron must have what, Lane? Well, so a cylinder has a base as well, so does a cone. But something about the shape. Natalie? It has to have a polygon for each face. Right? Polygon. So, why does a cylinder not classify as a polyhedron? Marco? Circle is not a polygon, right? Some people try to make it a polygon. It's definitely not. By definition, a circle is not. That's why a cone obviously is not here, or obviously not as a polyhedron as well. Okay? Now, something that we've talked about already here, and this is how we're going to wrap it up. If you flip this over one page, go to the next page. Something we've already talked about here with cross sections. Remember, we encountered a question about cross sections way back when we were doing some warm-ups for the PSSA, right? So we've had a little bit of discussion. Now, today we're going to formally define it. First of all, the first definition it asks for is that of a plane. I know you guys know what a plane is because I've asked my other classes and they've been able to answer this. So in geometry, could anyone describe to me possibly what plane means? Weston? Could be, yeah. Yeah, it could be sitting on a plane, absolutely. Yep. Riley, you want to add to that? Yeah, and that's true too. I agree. Lines sit in planes. Two-dimensional shapes sit in planes. Jake? Yep. Okay. Okay. So like the way Jake is showing, he's absolutely right. So imagine like this, my board here. Like imagine this, the way he was motioning is that it can go like out, right, side to side, but it's not going to go up. But if I turned it this way, then you'd say, well, it goes this way, and all the other ways, right? So the way we would define a plane is a flat surface that extends infinitely in all directions, kind of like a wall. Just imagine like a wall that just goes on and on forever. That's what a plane is. Flat surface that extends infinitely in all directions. And the next definition, that of cross sections, which we've had a little bit of a discussion about, but cross sections require a plane in order to be created because a cross section is the shape formed when a plane will intersect a three-dimensional shape, a solid. So the shape formed when a plane intersects a solid. And we're talking about a two-dimensional shape that gets formed when you do that. And I'm going to go through some examples with that here in a minute. I don't know if I'm going to have you draw. Like underneath there, it's asking us to draw a different perspective. I don't know if I'm going to do that, because I think our discussion today will be enough for you to understand what it is. So here's my makeshift plane, this board. So imagine I took a cylinder, let's say, and I cut it. Like a plane that extends infinitely in all directions slices through this cylinder. And we're going to slice this in a way that it slices parallel to our bases. Okay? So imagine here's your bases. It comes right through here and slices it like that. What shape, what two-dimensional shape would be formed when that actually gets cut? Zoe, what do you see? Circle, right? It's going to cut through, and the outline is going to resemble a circle, okay? So then what would happen, or what shape would be formed if I cut not parallel to the base, but perpendicular to the base? So imagine I chopped down through or sliced like that. What are we looking at? Maddie? You're looking at a rectangle. Now I can show you, like if you look up here at the board, like I'll try to do this. If I cut, I know my hand's kind of in the way, but that would be a parallel cut to the base. See how it's just a circle? This would be a perpendicular cut, kind of like that, okay? You guys have done some perspective drawing, I'm sure, before, but this kind of emphasizes that. Imagine if I took, so let me do one more and then I'll go with that example. Let's take this hexagonal prism here. What if I cut parallel to the bases? Boom, like that. What am I going to get? Jake? You're going to get that. Yep, you're going to get that shape right there, the hexagon. Okay? What if I cut perpendicular to the bases? Riley? You're going to get a rectangle. Okay? Okay, so what I started to say earlier, and I backed off. Imagine if I had two people take this hexagonal prism and this cylinder. Okay, two people, one's holding the cylinder, one's holding the rectangular or the hexagonal prism, and they walk all the way down to the end of the hall, all the way down there. The rest of us go stand down at this end of the hall between like Mrs. McDonald's room and Mr. Hines' room. Okay, and all I ask them to do is just stand there and just hold these two shapes like this. Are we going to be able to tell from that distance that they're different? Probably not, right? Because we lose that perspective. We're so far away that really all we're going to see is that outline. And both of these shapes would have the same rectangular outline. You wouldn't be able to tell. I could even add another one into this. Like if I took this triangular prism right here, I could have a third person standing there holding this. Wouldn't it look the same? They're the same height. Okay, so if they were holding these three completely different shapes, and then they, later on we said, oh, they're completely different, you'd say, well, okay, that could have been true. But you wouldn't have been shocked if I said, well, they're all the same shape, because they're going to look the same. Now, if they all turn them this way, then you're going to have a little bit different. All right, now you should be able to tell that they're going to be different. Okay? What happens when I slice a cone parallel to the base? What cross section do I get? Parallel. Lana? You get that? What if I go vertical? Like perpendicular here. What do I get, Natalie? You get a triangle, right? Okay? Pyramid. We'll do this. Pyramid. Like this is a square pyramid. So if I cut parallel to the base, I get a, just say, square, perpendicular. Okay. I've got a cube. I've got a cube. Parallel to the bases. Well, what's the defining characteristics of a cube? All squares, right? 6 square faces, all identical. So if I cut, well, all right. If I cut here, it's going to be the same. All right. Sphere. What if I cut vertical? All right. What if I cut horizontal? Do you see what's happening on the screen? It's always a circle. All right. So now, when you see the concept of cross-section, now you kind of understand what it means. It's a perspective. It's if you're looking from a long ways away, what are you going to see? Okay? So let's not worry about drawing any of those down there. You don't need. There's a couple images that you could look off of, but I think that's pretty good. All right, let's shut it down for today with that.